polymorphism. That is 2, and the last one should be interface. So these 3 things are what we're going to be talking about today. But I'm expecting that you already have an idea of what polymorphism means. Did my colleague take that with you? Okay, you didn't go into details with that. Okay, no, we'll treat that today. What about interface? Did he make mention of interface?
There are some parts that is free in
Polymorphism. Okay, no, we'll try and go deeper into that today. So I'll start with inner class. If you went through the video I sent you guys on the group chat, the person actually made use of inner class. So inner class is basically a class that is inside a class. So if you can see my screen, I'm assuming that you can. If you see here, I created a class. So I called this one example. So this is a class for this particular file, particular Java file. But I also have the liberty of creating another class inside of this one. This is what's called the inner class. And to do that, you start with the normal keyword that you use when creating this other one. You start with this keyword when creating the inner class. And for example, I could call it inner class. I could call this inner class, and it still behaves the way this other one behaves. But usually, when you do an inner class, it goes with the keyword static. And today we finally be explaining this keyword static, what it means. If I skip that, please do remind me to go over it. This static keyword. So just by doing this, I've created an inner class. So everything I would have done inside of this outer one, I can go ahead and do it inside of this inner one. Now realize that I didn't use this public keyword as I did outside here when creating this other inner class. The reason is that Java would complain that you can't have an inner class that is public inside of another. If I remove this static now, yeah. So if I try to compile this code, it would complain that you can't have this inner class the way it is here inside with the public keyword inside of this outer one. I called example. So to just remove the static keyword whenever you are creating the inner class, public whenever you're creating the inner class. So everything I would have otherwise done inside of this example, I can as well do it here. And by everything I mean I mean by you creating your field variable. For example, int a equal to b. So this is a field variable. I could create a method. Let's say public a method that returns void. Let me call this method. So these two things now are safe here. So in all, I think one of you, was it Jennifer, used it in the assignment, and the video I sent to you, that was the way it was demonstrated here. So usually when you need to create an inner class is when a class has a set of behavior that is like a collection of set of behavior that should be bundled together separately outside of the normal way you would treat this other class. But it's only in rare cases that you would need inner classes. In rare cases. But when the need arises, okay, usually you need inner class when you have a set of behavior that are alike, that are different from the way you would normally have outside of the way you create a basic class. It will make full sense at the moment, and I can't even think of any example. I can't think of any example. Okay. Okay,
We are preventing
let's say
you are not calling the class.
I'm trying to think of a good example, and no one is even coming up. So I don't know. I don't know. Hopefully, before this class runs out, I should have come up with something. But for now, just know that you need these inner classes. You need these inner classes where you have a set of behavior that behave alike, and you just bundle it up together inside a class. Otherwise, if you don't like, you could as well just put all of them as you would with a method. All the method that you would otherwise put inside here, you could instead of you putting it inside of this inner class, you could as well just carry all of them out and put outside of here, and everything will still be fine. That gives you the ability to have a class inside a class. And remember that a class is just a blueprint of creating an object, a template, basically. So you may not want to go deeper into this inner class for now. And hopefully, if I can think of an example, I would bring it up to you guys. So we just stick to the normal basic class that you guys have always known. That's this example. So I will clean this one for now, or maybe I could leave it for those that may want to go over it. I'll carry this. I'll carry this and put it back here.
They cannot inherit from any except
1 second. Okay. Someone is. Who is that? Okay, Abigail. All right. Okay, this needs to be closed. Okay. Okay, so the other thing I have on my list should be, what is it? Polymorphism. Jennifer and Abigail, what's up? You guys didn't come early today. Why?
Once that pot is running, I should just go and fix this thing on that.
Yeah, good evening. Okay, Abigail. Okay, no, I think it would be more helpful. Sorry? No, okay, so one thing you could do is to use a reminder to help you, to help remind you whenever the time comes. Otherwise, you could just be skipping the time for the class. Anyway, that's just for next time. So the other thing I need to mention is on polymorphism and interface. So we'll go with polymorphism first. So polymorphism basically is a way of is used to create two methods that have the same name, and I'm coming to that shortly. If you look, you remember the name of the method is the one given just before the opening and closing parentheses. So here, the name of this particular method is called main. Now, it's possible for me. Now it's possible for me to create another. I wouldn't want to go with this main now. It's possible for me to create sum and say that it takes in a value, and then create. Normally, if in Java, if I went ahead to do this particular thing I just did, say for sum, and say it takes in int a, Java would complain because these two things are identical. They are the same, and they perform the same task basically. So this thing is giving us a compile time error. So compile time error, just know that that Java is trying to understand what sense out of what you just written here, but it's not. It's not expecting this a method with the same name and the same input types. Now, but now in Java, polymorphism gives us the ability to have two methods with the same name. In this case, sum, but then the input type may be different, and then it stops complaining. So this integer tells us that what the parameter that is expecting should be an integer, and for this one, it's telling that the parameter is expecting should be of type string. So these two input types makes this thing different. And this is what polymorphism is. Now polymorphism, if you go into polymorphism, there are two types of it. The first is the overloading, and the second is overriding. Now the one you just witnessed is called overloading. Overloading in the sense that this particular method with a name is giving more function that more than one function basically. Every method typically is performing one function, but now you're adding more functions, you're adding more tags to this particular method sum. Now, not only can you change the input type, it's possible for me to still have int a. In this case, it's complain. But another thing that can make this different from the first one, this particular one, is the number of parameters that you're supplying. So this is a case where we have a method that is different from this other one, although they have the same name. So the number of input types is what for this one is what makes it different from this other one, or the type of parameter that it takes in. In the first case, it was string integer. Now it is integer. So does overload make sense to all of us if I get to the overriding? Does it make sense? Any questions on that? So it's clear to all of us. That's fine. So to demonstrate the overriding, I would have to create another class. I'll just call this another class, and you guys already know what how to make use of the extends keyword. That's for inheritance basically. Now I'll go ahead and create one method here. If I have to tell you what overriding here. Now let's say the method name is a method. I'll just call it a method, and then the return type is of void. Let's say it's printing out a message. Let's say you just called me, and this is what is being printed out. And now let's come here. Okay, I'll comment this class. I'll comment this class for now. And this is our example. Let's say it extends another class. Now to demonstrate overriding gives us the ability. Now if you look here, this particular method you're seeing here, a method, what it is designed to do normally is to just perform this block of code that is inside here. And you all know that you can have many more blocks of code on that here. This simple one I'm using here is just for demonstration purpose. And if, for example, this particular one that has this block of code inside it, and the work is to print out, you just called me, right? Now I could go ahead, because I did extend this class here. Because I did extend this class that's into this one, it then means this example basically does everything that this one does. If I went ahead to create more method, 1 second. So if I went ahead to create more method or anything inside of here, as this particular one example, we inherit every of those attributes, every of those functions. It will inherit them, and it will behave the same way I've defined it inside of here. What that means is, if I come here, I could anyway, to do the overriding. Basically, it means that you start with this annotation you're seeing here now at override, and then call that method that is in the parent class, which in this case is another class, right? Call that method. What was the method? I'll just copy this. Let me type it in for void a method. Now, with this override, In plain English term, you understand what overriding means now, meaning to take over the way something behaves. So with this override, I could go ahead and tell it to not do what it was originally designed to do, which is to perform this action here, to print this message here. I could tell it that it should in fact do another thing. Let me not just shout. Let me not keep shouting things. I could tell it that in fact you should do what? Do int a equal to 2 and b equal to 6. And then it should perform what operation? It should shout the result after it is added to b. Does this make sense? Abigo and the rest. Jennifer, Bukola. Am I alone? Speak up now, come on. I should come again. What's the yes for I should come again or it makes sense? Which one? Yes for. Okay. Okay, so let's start with you're in the kitchen. Better pay attention. Okay, let's start from here. We have our class, we have this class, example, and then we have second class, another class. This another class has all of the attributes or methods or functions or field variable that we've defined here. In this case, it's just one. I could go ahead and put in more methods here as I like, but I'll just stick with this one here. Now, every of the thing I've defined inside of this class, I could tell it that I want you to come and act inside of this other class, example. Now, what that means is that if I don't override this a method, wait, let me comment this out first. Now let me create a main class. Let's say PSVM, public static void main. So this is short for it. Yeah. So let's say I need an instance of example. And when I say instance, I mean I need to create an object of example equal to new example. Now I could do example dot a method. Now if you look, let me delete this. If you look, that a method was not this a method you're seeing here. It was not explicitly defined inside of this class. If you look from top to bottom, from top here to bottom, this thing is commented. Don't look at this part. You can see that I didn't define that particular method in here. Now, how is it able to perform this function now? A method. Could any of you answer? This object I created here is from this class I called example. But I didn't in any place define this method a method, and yet is able to read it and not complain. If I went ahead and say B method, you would observe that it's complaining, and that's because it's nowhere here. It is nowhere here. There's nothing like B method here. But if I went ahead to change this to A method, you would observe that everything is fine and it's not complaining. Is there any idea on why it's not complaining from any of you? Which one? Not quite. The reason is that if you look inside this method, another class, I have this method here, a method. Let me delete this. This means that there could be more blocks of code. If you look at inside of here, you see this method It's just one method here. I could have more. You get? I have just one method inside of another class. If I come to example, now this my example is inheriting another class. And what that means that it is taking the properties, every property that I've defined inside of it, including this method here. So because of that, even though I didn't explicitly define here that that method, a method, is more like an extension of this example class, extension into this other one. So regardless of me whether I wrote it down or not, this particular method, a method, still exists in here because I extended this. Does this make sense to us? No, because it's standing alone here. It's not an inner class. So inner class comes up whenever it is inside of another class. Do you understand? So inner class is a class that is inside of another class. But whenever it's standing alone here, it's just a class of its own, not an inner class. You can consider it as an outer class if that works by you. So does this make sense to us? Jennifer, Abigail, another. I need your responses. What about the other two? Or do I need to say it again? Ah, Abigail. All right, so I'll take that as a yes that you understand. So I'll go to my method overriding, which I was mentioning earlier on. Now, since you now know that this method, which I created inside of here, that's a method, is existing here, even though I didn't mention it, I didn't write it out. What I could also do is to tell it, sorry, and if you observe, let me run this, so you see what it prints. So this particular method now, what it does is to what? It prints you just called me to the console. That's what this particular method does. So by text inside of my console. So this is it. Now I want to take it from here. This particular behavior, which was defined here, can be overridden and given another pattern of behavior. And that's what overriding helps us to do. And to do that, you must have to type this thing the way it is here. Let me just copy. If you look, I was using the static, whereas in fact it's not even there. If I went ahead to type any other thing that is not this signature you're seeing here, this public void a method, it would mean something else. So to override it, I have to write it the way I did it in the parents class or base class here, and then give it another pattern of behavior as I like. Let's say x equal to 2 and y equal to 5, and then it should go ahead and print x plus y, which is 7. Now if you come to this method here, it will not behave the way it behaved earlier on. That's why printing you just called me. It instead would behave this way that I've defined it here. It will perform this block of code that I've put in here. In fact, I'm expecting 7 in the console when this thing is on run, and not you just called me. And you can see that here 7. So you can see that here 7, and not the original behavior that it was defined to have. Please, does this make sense before I go ahead? Yeah. Yeah, I can hear you. Someone who called me. Abigail, I need to hear your voice. What's up? Abigail. So Bukola and Ada. Where is Ada? I can see her here. Is she here? Okay, Ada is here. Bukola and Ada. Does this make sense? Before I go ahead, please, I need a response. Oh, oh. Okay, was that what she said earlier on? Oh, oh, let me read that. Okay. Oh, oh. So sorry then. So sorry. What about Ada? Okay, that's good. So just a recap. By the use of this override, I'm giving it a different behavior than its parent. So its parent was defined to behave this way, but now I'm coming here, I'm telling it, don't behave that way. I need it to behave this way. So these two things we just treated is what polymorphism is. Now this override, remember overloading is a type of polymorphism because this sum has the same name with this. Now observe that this a method also has the same name from its parent class, a method, and that's why it's considered polymorphism. Whenever I think of polymorphism, think of two methods that have the same name. Okay, that's fine. So that is it for polymorphism. The okay, I initially said we'll be dealing with interface today, but I think we need to do with abstract classes first before the interface. So in abstract classes, is a special type of class. Second, apps class. I'll just call this apps class. No, I don't need this. Now to create an abstract class, you start with you put in the keyword abstract. Now abstract class is a special type of class in the sense that it gives us the ability to just create the skeleton of a class. By skeleton, I mean creating all this, writing all this method you're seeing here. Say sum, say a method, say any method basically, but then not define their body. Now there are two types of classes: the abstract class and the concrete class. The one you've always known, this one will be playing around with ever since. That's what they call the concrete class. Now, in abstract class, it gives us the ability to what create a method and not give it the body. And now by body, I mean everything we've typed in here, all of these blocks of code. That's what I mean by body. Because I have this opening and closing bracket, this is also a body, even though I don't have any line of code here. This is a body as well, but in this case, an empty body. Now in abstract class, I can have the ability to, let's say, create a body and say first body. Let me just call it this. Now it's complaining. I want to remember I said you can decide not to give it a body in abstract classes. Now for this to be fine, you have to use the abstract keyword to tell it that this actually is an abstract method. This is a method because of the way I've defined it here. Observe the pattern we've used in creating methods before. We put public, we put static, we put, please help and remind me to define the static later. We put public, we have the statics. This statics is optional, but I'll tell you the reason and when to use it. We have the void, we have the method name as well as the parameter. That's if it will be having any parameter or not. In this case, let's say it doesn't have any parameter. And just say, let's call it first body here. Now observe that I didn't, okay, let's say empty, empty body. Now, if I remove this abstract class, this would complain as you saw earlier and as you're seeing now. But for me to make this an abstract method, that's the word to use for it, abstract method, I have to use this keyword that I've created here. And if I don't put the abstract class here, you observe that everything here is in red. It's complaining. And that's because I didn't tell it that this should be seen as an abstract class. And to do that, I have to make use of the abstract keyword on the class level when creating the class abstract here. Now I can go. I can as well go and create as many bodies as I like. It could be. Let's say this is another abstract. Let's say this one is returning a string. It mustn't be void. Let's say empty body 1. Let's say this one takes in a parameter. Let's say string s1. Let's say 2 parameters. It takes in 2 parameters string s2. So this is telling me that it's a typo. And remember your camel casing to make the B capital. So if I make it capital now, life is good. Now, not only can I define the method signature, this thing as it is written here is what I refer to method signature. So not only does abstract class give us the liberty to create a method signature as you've seen here, I can as well decide that I also want to actually have a class. Let's say this one returns boolean. Let's say return boolean, and it takes nothing. I can as well create the normal kind of method we've always known. Let's say int j equal to 22 and int k equal to 41. And now I want to, let's say boolean bool equal to j greater than k. So this will resolve into something. It will check if j greater than k. In this case, it is not. It is false. And let's just return bool. All this one I'm talking just for demonstration purpose. So we don't always keep putting in the empty body. So let's say we have this block of code inside of this method now. And then this particular method, I've defined the body basically. And what is to perform is to do is to perform all of these operations and return the result afterwards. Now with this method, it's giving me the ability to create the body, but with the abstract method, it has given me that ability as well not to create the body. Always note that you need to make use of the abstract keyword if I decide that I don't want to put the body yet. Before I go ahead, any questions? So this is clear to all of us. Which side? Which side of it? This one? All right. Okay, this one is not clear to you, Ba? Okay, that's fine. Now observe that. Sorry? No, this is standing on its own. No, this is one method. This is another method. This is another method. So in total, I have 3 methods. This is starting on its own. Observe that I use this semicolon here to terminate it. Exactly. So this is one method, although this method has no body, because why? It is abstract. This is another method, but it has no body, but it's still a method nonetheless. And now this is my 3rd method. This one has body, and that's why I didn't go ahead to put in abstract here, abstract keyword. So you mean here? What I'm returning is this value here. After evaluating is j greater than k, it will resolve to true or false now. Do you remember? Yeah. So my J is 22 here. My K is 51. So it will check is J greater than K. I know this will evaluate to false, and eventually it will return false here. So this one is just to return whatever this is afterwards, after evaluating. Now don't look too much inside. Don't look too much at this. I could decide to clean it and just tell it to return false. This is just the normal method you've always known. Ada, is this okay to you? Now I put this just so we don't just keep having empty body. I just want us to establish a body, some lines of code. I don't want to be using the south like I did here. I could have decided to south just one line of code, but just so we expand our distance thought process. So this is the body for this one, and now back to this abstract method. Now this is the thing to note. Yeah, yeah. Here, right? Yeah, yeah. The reason is that I'm actually giving it a body. That's the reason. But this one, if you observe, I didn't open this thing and start giving it any body. And if, in fact, you can see that it's complaining. Sure, you saw it. Are you seeing it? It's complaining because I told it that I want this to be abstract method. You want it to be abstract method, and now I'm trying to give it a body. But if I went ahead and removed this, it will be fine. This will be fine now. But I want it to be abstract body, meaning that I don't want to give it a body yet. But later on, you must have to give it a body if you want to create an object out of this class. And we're coming to that. But is it clear to you, Bukola? Why I didn't give it a body? Yeah. So I didn't give it a body because I want it to be an abstract method, and I give it a body later on when I want. But for now, just keep it as empty body. So this is an abstract method. This is also another abstract method. This is not an abstract method. And you can see that by me not using the abstract keyword. Now this is the thing to note about abstract classes. You saw the way I created this normal class here. It's not an abstract class. I didn't use the abstract keyword. And I was able to create an object out of it. Now this particular one that is an abstract class, I cannot create an object straight out of it. And the reason for that is part of what you're seeing here. The reason for that is I have some method, but I don't have the definition for the body. And therefore, at some point in my code, for me to use everything that I've created here, I would need to supply a body to all of these methods. Remember, I mentioned two types of classes: the abstract class, the one we're treating now, and concrete class, the one you've always known. And therefore, for me to make use of any of these things, I would have to extend this particular abstract class into a concrete class. Concrete class is the one you've always known. So I'll pretend that this particular another method, let's now say that it is the one that is extending that abstract class. Let's try to create an object from that abstract class. Let's say apps. Let's say apps abstract class equal to new apps class. Now observe that life is not good here. This is the way we've always known to be creating method. And now I'm trying to create another method of this abstract class, and then it's complaining. Now why is it complaining? It's complaining because I told it that this should be an abstract class. But then I don't have body for this one. And therefore, if I wanted in future to make use of, say, apps class dot, let's say empty body, it will end up not performing anything. This empty body here now, it will end up not performing anything because I didn't even tell it, I didn't give it any block of code to perform whenever it is called. So to start with, this would not work. This will give you the compile time error. Anytime you're seeing red on your IDE, it means compile time error. The other type of error is the runtime error, which comes up whenever you want to execute your code. So runtime errors, you don't usually find them here. You don't see them. You don't see all these red marks you're seeing. It comes up whenever when you try to run your code, and then usually you see those errors in your terminal here. It will be showing here in your terminal. Those ones are the runtime errors or compile time errors. You're seeing them straight up by this red you're seeing here. So it means that you should correct your code and make it readable by the program. So for this apps class, what I can do is to, for example, extend it into another class, the one you know as concrete class, this apps class now. And now you cannot extend an abstract class by not implement the methods, and that's why this thing is complaining. So it wants you to carry all of the methods that I've defined in here and bring it to life inside of here, and that's the way abstract classes work in Java. And you can see I just use the magic IntelliJ does for us by providing all of those classes. And now what do you observe? Now if you look closely, this empty body and this empty body ones, they are the ones that I initially defined to have no body. This empty body and empty body one, they have no body. And this one with body was not included. Not here. This one now that has body was not included here. I mean, where is it? This particular one, the return boolean, was not included when I did that extension here. So this method is that old one. This empty body is the one that was defined to be abstract, and now this other empty body one is the second one that I defined to be abstract. And now what this means is that it is at this point that I want to give it a body. It is at this point that I therefore want to give it a body. Now if I went ahead to give it a body, if I don't come to my main, what that would mean is that I want to make use of this my abstract class, but then to make use of it, I've extended it into another. What I will now do is to create an instance of another class. Let's say another class. Now I'm able. No, I'll share these files with you, so you're able to compile it later. Now this another class is one I'm now able to create, and now this empty body would do whatever I want it to do now. So the points to note is, let me put down some comments. I could do that later before sharing the file. The points to note here is that listen closely. When I define an abstract class, it gives me the ability to create methods and not give them body, as you're seeing here. This one is not an abstract method. Yeah, this one is clever. Yeah. But if I want an object out of this particular class, apps class, I can't do that because I didn't give this thing a body. And therefore, program cannot understand whenever I want to make use of this method, empty body, the way I've done with this one now. It's understand because I've given it this block of code to execute. Now, if I want to make use of this method, what I must do is to extend it into another class. Remember what extension is. It means that you're inheriting the properties initially defined. And in this case, the property here is this method and this method. By default, you have this override here because it is now here that I want to define. Remember this. This is a polymorphism because they have this empty body, which is the same thing I defined here, and then this empty body one, which is the same thing I defined here. They basically have the same name. That's why you're seeing this override. Only the difference is that it's not having the same behavior that it has in this abstract class, even though the behavior is not particularly defined. But here, it should take the behavior I specify here. Let's say here I'm printing Adama. and this other one, let's say I'm returning my my string. So basically, this is the points where I've defined the body. This is the point where I've defined the body for this one, and not here. I could as well override this other method that we have here. I could as well override this method that I've created here. Let's quickly do that. To do that, I would copy this signature here, or you could go through the route of typing it out. I could copy it and say override. I would paste this and then tell it to return something else. Tell it to do something else basically. Let's say in this case it's returning true, because my return type is boolean now. Let's say in this case it's returning true, but here it's returning whatever this thing evaluates to be. In this case I know it's false because it's asking, is j greater than k? Our j is 22, our k is 51. So is j greater than 51? Is 22 greater than 51? So this will result to false. So this is as good as saying that bool is equal to false. And then I'm coming here to return false. So inside of me, I know this is actually false that is returning. But in this case, let's say I want to return true. That means I'm overriding the initial behavior to perform this other behavior that I've defined here. So it's optional for me to override this one, in which case it will now perform the actions I've defined here. But if I don't want it to perform the actions I've defined here, I could as well just override it and treat something else here. Ask your questions if you have any. Ada, do you have a question? Your mic is unmuted. Oh, is that Bukola? Who? Any questions from any of you? Or are we fine? Yeah, go ahead. Yeah. Yeah. Yeah, these two. Yeah. Yeah. Exactly. No, if you want to give it body here, you can do it just as we've done here. But it will mean that you remove this abstract keyword. Let's say I attempt to give this one body. With this abstract keyword, you can see it's complaining. It's now telling you, oh, you want to give this body, then you should remove this thing and go ahead and do whatever you want. But since I don't want to give it body, I'll just use the abstract keyword for it to recognize that this should be like this with no body, and the body will be implemented within any class that inherits it, like we've done here. So you can see that I extended that abstract class, and now I'm giving it a body. And if I want to make use of the body, I would therefore now make use of, if I want to create an object, I won't go ahead to create an object of abstract class. You can't create an object from abstract class. You would instead create an object from the class that's inheriting it, as you can see from here. Is this clear? Any other questions? Jennifer and Bukola. If everything is fine, just let me know. Who is speaking? Jennifer? What about Bukola? Okay, very well. I will intentionally not proceed to answer that static keyword today. I think we already had enough for today, but try to read it up for yourself if you want to know, or you could just wait for me to explain it. I think you already have enough from this class today. Yeah, so if you have any other thing to say, you could at this point. I could just go ahead to end the class. Why should real class we warrant doing abstract? Okay, basically, it's most of the time, in fact, you are advised to use abstract classes. I wouldn't say most, but in many cases, since you don't know the, it's possible that this class, this particular abstract class now, it's possible that you don't know the behavior. Initially, when we did the normal class, you saw the, when we started with OOP, you saw human, you saw with those examples, human, woman, and man. Now, it's possible for me that I create, the examples we used that there was has mustache, we use has what, long hair. It's possible that I can come here and just create the those methods, has mustache and has long hair. Two of them return boolean for us. And then what I could do, and that class I would call it human. What I could do is then to create those two other subclasses, that's the man and the woman, and then define whether they return has mustache, that's if it's true or false, and then for the hair, return true or false for each of the cases. Instead of me having to, instead of me having, since we don't know what the answer is yet, and we don't know the behavior basically, we shouldn't go ahead to implement the method. But we know that for sure we need that method, but we don't know the behavior yet. So these situations are when you need to use abstract classes, when you know that it has this body, but you don't know the behavior yet. Now another example is I could have a class called bird, and then I have a method that says can fly. Now if I went ahead and said and implemented in the body and said return true, what about ostrich? If ostrich goes ahead to extend from that class, it then means it will return true for ostrich, whereas ostrich cannot even fly. It will work fine for parrot because parrot can fly. If I extend that class, it will return true because parrot can fly. But if I do that for ostrich, it will return true, whereas ostrich cannot fly. So what I can do is to just to define the body. Let's say, let me type it out so it makes sense to you. I could define, I say abstract, abstract. Let's say return boolean can fly. Yeah. So whatever class that will extend from this, will not go ahead and just return. If I went ahead to, let me not skip. If I went ahead and did something like this and say return true. Now if parrot extend this class, it will return true. If ostrich extend this class, it will return true. Now because I don't know the situation, I will just leave the implementation for whoever extend this class to decide whether they return true or not. What I know is that I know those are birds, but I don't know if they can fly. So I'll just define it this way, and that would be all. And because I just put this particular method here, and because I said it's abstract, if I come to this one that is extending it, it will be complaining because I created one more method that is abstract, and I must have to implement and give it a body. Otherwise, just remove it, and life is good. Does that answer your question, Abigail? You can just, okay, it's out already. Well done. Any other question? Any other question? All right. All right. If you've not submitted your assignment, endeavor to do that before the time runs out tomorrow. Okay, that will be all till our next class. Good night, all. Yeah. Okay, yeah, I said I was going to give you an example. So I think I'll just calm down and find the perfect example. So I don't give something that is not quite clear. So I'll just find something that makes perfect sense and hopefully it clicks. Yeah. Yeah. And good night, guys.